extremely bright. It can be observed billions of light years away. It was expected that the expansion of the universe was slowing down. The result is the opposite. The expansion of the universe is accelerating. Something is gaining more and more power. Push the space away. The gravitational pull that overwhelms all matter in the universe. Scientists call this mysterious force dark energy. It accounts for 68% of the total intelligence of the universe. But the connection of dark energy to the voids of the universe, it's much more than driving inflation. The void is where dark energy wins. In the ordinary regions of the universe, the density of matter is high enough. Gravity can overwhelm the repulsive effect of dark energy. Thus, galaxies are formed and maintain their structure, even if the universe as a whole is expanding at an accelerated pace. But in the hollow area, the density of matter fell below a certain critical threshold. Once this happened, dark energy completely prevailed. It not only prevents new galaxies from forming, it will also take the initiative to push the existing material away from the center of the cavity. Let the hollow become more and more empty. This creates a positive feedback loop. The hollow is empty. The stronger the dark energy inside, stronger dark energy and more efficient expelling matter make the hollow even more empty. This process accelerates over time. The latest calculations show it is this feedback mechanism explains why superhollows are growing at a rate far beyond the scope of what can be explained by the expansion of the universe alone. The woody hollow is not just a passive expansion with the universe. It is being actively drained by dark energy effects. But even more disturbing is the connection that follows. Some theoretical physicists now propose hollows may not just respond to dark energy. They may be creating dark energy. This radical view believes dark energy is not an inherent property of space itself. Instead, it emerges from the structure of the cosmic web. As the cavity expands and merges, they are somehow stretch the spatio-temporal structure. This produces the repulsive force we observe. That is, dark energy. If this theory is correct, he will be able to solve one of the biggest puzzles of cosmology. Why? Dark energy began to increase significantly about 5 billion years ago. That happens to be hollow evolution, the point in time to enter the current acceleration phase. The timeline fits perfectly. In the early days of the universe, the hollow is still small and isolated. The dark energy effect is weak. But as the void grew larger and began to merge, they spun stronger and stronger dark energy feedback. It has now dominated the evolution of the entire universe. This means the ultimate fate of the universe depends on the dynamics of the hollow. If the void continues to expand and merge, dark energy can be so strong that it overwhelms all other forces. Finally, in the big tear scene, completely shredding galaxies, stars, and even the atoms themselves. But the connection between emptiness and dark energy also offers hope. If the void is really a generator of dark energy, then study their internal structure. It may reveal how this mysterious force works. Scientists are now using unprecedented precision, mapping the characteristics of the cavity. Look for hollow features and the intensity of dark energy. The initial results are encouraging. The largest and emptiest hollow, it does show darker energy effect than small cavities. The generative hypothesis is supported. What's more, a study of the hollow may reveal something. Whether dark energy is really constant, it will still change over time and location. If by energy it is generated by the void dynamics, it should evolve with the hollow and predictable fluctuations. These measurements may ultimately answer that ultimate question. Our universe will expand forever, or will eventually collapse back to itself. Imagine a soap bubble floating in the air. The film that wraps it creates surface tension, maintaining a spherical shape. The air inside the structure is pushed outward. The surface tension is pulled inward. Form a delicate balance. Keep the bubble stable. Now magnify this bubble to 330 million light-years wide. Swap the soap film for dark energy. This is exactly what it is now, the way some scientists view the emptiness of the universe. The latest theoretical research suggests the hollow is like a giant bubble in spacetime. Its boundaries, formed by the interaction of ordinary matter with dark energy. Just like soap bubbles are affected by surface tension, hollow boundaries may also have some characteristic, influence how they expand and merge. Surprisingly, the math behind this model, surprisingly similar to bubble physics. When two soap bubbles come into contact, the surfaces will rearrange to minimize the total surface area. When two hollows meet, their boundaries may merge in a similar way to minimize the total dark energy density. This bubble model explains multiple mysteries in hollow behavior. Why hollows tend to be spherical instead of irregular shapes. Why the merged cavity border is smooth and rounded instead of chaos and shattering. Why is the emptied substance mostly gathered on hollow walls? But this model also predicts something even more striking. Hollow boundary. It should put pressure on the surrounding substances. It's like a pressure difference inside and outside a soap bubble. Hollow boundaries may also push outward neighboring galaxies, mass and filamentous structures. This pressure may explain why hollow edges often lined up with unusually dense galaxies. This pressure goes both ways. The material at the boundary of the void is pushed backwards, inhibits cavity expansion. The cavity pushes the material region outward. Ouchium. A cosmic pressure system was formed. Let the cavity interact dynamically with the filamentous structure. Recent observations support this pressure model. Stars near the boundary of the void. The fellowship shows signs of being compressed and heated, consistent with the pressure generated by the expansion cavity. And the galaxies inside the hollow, it shows negative pressure dominated by energy, stretching and cooling features. But the impact of void pressure goes far beyond individual cavities. If every hole in the universe all put pressure on its surroundings, so the cumulative effect may explain the accelerated expansion of the universe, without assuming that dark energy is an inherent property of space. Billions of them spread across the cosmic web. Empty collective pressure. It may be enough to accelerate the expansion of the entire universe. This means dark energy may not be some mysterious new force, but only on a cosmic scale. Natural results of cavity dynamics. Computer simulations to test this hypothesis. Encouraging results have been shown. Models that include the cavity pressure effect. There is no need to introduce additional dark energy components. The observed cosmic acceleration rate can be reproduced. The pressure model also makes testable predictions. If the cavity is the stressor, their expansion rate, it should be related to the density of the surrounding matter. A hollow surrounded by dense clusters of galaxies. Expansion should be slower than cavities in sparse areas. Initial measurements support this prediction. Systematic expansion rate differences are shown, consistent with the expectations of the pressure model. But the most profound implications concern the future of the universe. If the acceleration of the universe stems from the pressure of the void, instead of basic dark energy, then the acceleration rate, it will change with the continuous evolution of the void. This means that the ultimate fate of the universe is still uncertain. It will depend on the expansion of the cavity and the distribution of the material, a complex game in the long universe. And this is the problem that keeps cosmologists awake at night. The Murphy Hollow should not exist now. According to our best model of the evolution of the universe at the moment, to form a diameter of 330 million, the time it takes for a light-year hollow, it is longer than the 13.8 billion years since the Big Bang. Any known process by which supercavities are formed, it will take at least 150 to 20 billion years. This time contradiction is not unique to Morpheus. Throughout the observable universe, multiple supercavities seem to large and mature. It does not match their age. This is like you're in a forest that was planted only 5 years ago. Suddenly it was discovered that towering oak trees had grown. The root of the problem lies in the formation mechanism of the cavity itself. The quantum ups and downs of the early universe. It does produce areas that are slightly below average density. But these initial differences are extremely small. The density difference is less than 1/100,000th. To let such a faint ups and downs grow into the huge open area we see today, it takes 1 in tens of billions of years. Are extremely fine and stable processes. Substances must be continuously pumped out of the low-density zone. Meantime, also avoid the gravitational attraction of the surrounding high-density area. Computer simulation display. This emptying process is indeed feasible, but it is slow to form. The model predicted a typical cavity with a diameter of about 100 million light-years. It would take about 10 billion years. Unlike the constellation of Wood, super hollow that is more than 3 times larger, it should have taken longer. To complicate matters, the expansion of the universe that drives the growth of the void, it is not constant. The first 7 billion years after the Big Bang, inflation is actually slowing down. Gravity gradually overwhelms the initial explosive force. Until the last 50 to 6 billion years, the dark energy began to expand at an accelerated pace. This means the growth rate of the void in the early universe. In fact, it is slower than it is now. The acceleration phase required to form a supercavity. It only accounts for about half of the history of the universe. However, the structural characteristics of many supercavities are indicated. They were already in a period when the expansion of the universe was still slowing down. It has already been formed. For this time problem, scientists have proposed several possible solutions. One of the solutions is, our measurement of the age of the universe may be wrong. If the age of the universe is far more than 13.8 billion years, that goes through the regular process, there is enough time to form a super hollow. However, there are several independent methods for determining the age of the universe. All point to similar values. This makes this explanation extremely unlikely. Another possibility is the formation of voids in the early universe. The efficiency is much higher than the current model predicts. If the dark energy effect is stronger in the past, or there are other unknown forces that fuel the growth of the hollow, super hollow, it may be more than the standard timeline allows. Faster formation. Recent observations. Some support was given to this idea. Research on the microwave background of the universe. The nature of dark energy may have changed with cosmic time. It may have accelerated the formation of early structures. But the most radical solution, that's right. We need to re-examine our understanding of the evolution of the universe. Hypothesis. If the universe has gone through many phases of rapid expansion, not just one explosion, then super empty, possible, early acceleration that we have not yet detected, has been formed. This will require us completely revise the understanding of the history of the universe. But it cannot only explain the time problem. It is also possible to unravel large-scale structures, multiple other mysteries in. Solve this time problem. New observation methods are likely to be needed. Detect the evolution of the universe with unprecedented accuracy. Whatever the answer is, he will be fundamental. Change. We have a good understanding of how the largest structure of the universe formed and evolved. 这是的马进. If the Earth was not born in the group of galaxies we are in, instead it forms inside the cavity of the wood sign, human civilization's understanding of the universe will be completely different. Our night sky will be almost pitch black. There is no galaxy across the sky. There is no naked eye. See the Andromeda galaxy. Neither did not. Distant star clusters inspire human curiosity and reverie. There are only occasional faint spots. From the nearest hollow galaxy tens of millions of light years away, early astronomers would conclude, we live in one, on an isolated stellar island surrounded by the infinite void. Other galaxies may not be available until the 60s. Rely on more powerful telescopes. Finally caught the faint light of those distant empty neighbors. We have a big bang about the evolution of the universe, and understanding of large-scale structures. This can delay by decades or even centuries. Questions about dark matter and dark energy. Perhaps it has not been solved to this day. But there is a profound understanding here. Albeit, we are lucky to be in the material-rich region. But we are just beginning to understand the true nature of the universe. Super hollow finds like Woody. It reveals that our cosmic neighborhood is actually very atypical. Most of the volume of the universe is a region of near emptiness. Galaxies formed there, for some reason that we still don't fully understand. We live on a cosmic island, surrounded by a vast and boundless ocean of darkness. Its scale far exceeds that of our brightest stellar city. The implications of this shift in perspective extend far beyond astronomy. He reshaped our perception of ourselves in the cosmic order, position cognition. It also changes our understanding of discovering other wisdom, judgment of the possibility of civilization. If most of the universe is too empty, unable to support the formation of complex structures, then the area that can give birth to life, it is much rarer than we used to think. Earth. It is located on the material-rich filamentous structure of the cosmic web, perhaps one of the luckiest addresses in the universe. But the discovery of emptiness, it also reveals the amazing dynamic nature of the universe. Seemingly empty emptiness. In fact, it is a battlefield of fierce confrontation. Dark energy and gravity. A tug-of-war is waged on a cosmic scale. The cavity continues to grow and merge over billions of years, reshaping the distribution of matter and energy. Our future, it depends on the outcome of this cosmic struggle. If it continues to increase by energy, the hollow will eventually completely dominate the universe. Galaxies will become islands isolated from each other. The drifter it gets, the farther it goes, until they each float alone in the expanding sea of darkness. The distant future, civilizations like ours, maybe you will face, like the Earth was born in the hollow of Jupiter constellation, the same cosmic isolation. The night sky will gradually become empty. Distant galaxies fade out of view due to redshift. Only local stars remain. It reminds us that the universe was once full of light. However, the discovery of the hollow, it also shows that the universe is in seeming emptiness. The amazing ability to nurture structure and beauty. The exquisite architecture of the universe network. Precise tubular structure inside the supercavity, and the complex dynamics of dark energy, all revealed. A deep order emerges from quantum chaos. Understand the hollow. It is now the key to understanding everything. They are not just gaps between interesting structures, but an active participant in the evolution of the universe, generator of dark energy effects. Under extreme conditions, a natural laboratory for basic physics operation. 700 million light-years away, the halo of Woody stares at us. It challenges our understanding of space and time, and shaping the largest scale of the universe, all the cognition of the power of reality. In this vast darkness, we see the smallness of our own universe. I also realize how lucky I am, can be in a universe that should be empty, dwell in a place where light and structure flourish, and in the depths of the seemingly empty hollow of the constellation of Wood, hidden is an invisible network spanning hundreds of millions of light-years. Magnetic field lines cross this cosmic wasteland. It is no accident that the pattern is too regular. These magnetic fields should not exist. According to our understanding of magnetism, magnetic fields require a moving charge to generate and maintain. But there is almost no substance in the cavity. The small amount of material that remains moves too slowly. It simply cannot form what we observe, this strong and orderly magnetic structure. However, the pair comes from afar. The measurement of the gamma rays to be variant is shown. When these rays pass through the cavity area, the path is deflected. The deflection pattern shows there exists a magnetic field that is at least 10 trillion times weaker than the Earth's magnetic field. But it can be at a distance far beyond the scale of the entire galaxy cluster. Stay organized. For example, it's like a spider web is found on the North American continent. Each silk thread is invisible to the naked eye, but it can maintain a perfect geometric structure and affects everything that passes through it. This magnetic mesh appears to pass through an invisible channel, connect the few remaining galaxies in the void. Computer model display. These magnetic field lines. It may guide the flow of residual rarefied material, like cosmic railroad tracks, transported along a specific path. This may explain why galaxies in the void, mostly concentrated in tubular structures, they don't gather randomly. Instead, it was established as early as the early universe, and the magnetic highway distribution that continues to this day. But what really makes these magnetic fields mysterious is this. They seem to be strengthening over time. The current magnetic field strength, compare with observations from decades ago. Magnetic networks that have found holes are becoming more and more orderly, getting stronger and stronger. This is in line with the law of magnetic field evolution as we know it. Completely contradictory. Usually as the universe expands, the magnetic field will attenuate and dissipate. This enhancement phenomenon suggests some kind of active process is being maintained, and this time the structure is enlarged, but it contains almost no substance, or the area of the energy source. What can produce such persistent magnetic activity? One could be dark matter interactions that we have not yet understood. If dark matter particles can weakly couple with the magnetic field, then there is a lot of dark matter in the void. Maybe it can be done without ordinary substances, organize and maintain the magnetic structure. Another possibility is these magnetic fields. It is the original relic left over from the first moment of the universe. Because there is too little material in the cavity, not enough to destroy them. Instead, it has become a space museum that preserves the early state of the universe. But the most fascinating possibility is the hollow magnetic field is actively generated by the dark energy itself. The latest theoretical research suggests dark energy may not be completely uniform. Instead, it has structures that we have not yet detected, and dynamics. If dark energy is pushing away space at the same time, it can also generate magnetic fields. explains why these magnetic fields are so orderly. And as the dominance of dark energy increases, and it continues to get stronger, if this conjecture is confirmed, magnetic field in the cavity will be our first direct detection, evidence of the internal structure and behavior of dark energy. But this leads to a deeper question. In the empty area of the universe, is there still other networks that we cannot see? The space itself is ringing like a bell, and the biggest whole, it is we who can finally hear the resonant cavity of this cosmic sound. Gravitational waves, the ripples of time and space predicted by Einstein. In fact, it travels through the universe all the time. But on Earth, we didn't use laser interferometers until recently. It can detect rho changes less than 1/100,000th of a proton width. The collision of a black hole with a neutron star was captured for the first time, the resulting gravitational wave. And the universe is empty. However, it provides an advantage that the Earth probe cannot match. Pure space on the scale of tens of billions of light years. Hardly anything. Interference with the propagation of gravitational waves. When gravitational waves pass through areas dense with matter, it interacts with galactic gas clouds and magnetic fields, causes scattering, absorption, and catastrophic change. It is difficult to restore its original characteristics. But in the hollow area, gravitational waves can travel almost undisturbed for hundreds of millions of years. This makes hollows like the constellation wood. It has become a natural cosmic gravitational wave. Observatory. Scientists have recently begun to take advantage of this property. Study the gravitational wave background. It is from countless sources in the universe. Continuous hum of spacetime. By comparison, properties of gravitational waves as they enter and exit the void area. It can separate the pure signal of different wave source processes. Preliminary results. Surprising details in the history of the universe have been revealed. In the background of gravitational waves, it contains the echoes of the first moments of the universe. Explosion period. Quantum ups and downs stretch to the cosmic scale. Phase transitions in the early universe. And the formation of primordial black holes. These ancient signals. It has been in space for more than 13 billion years, carrying something we cannot know otherwise. Early cosmic information. But the emptiness reveals more than just ancient history. They are still doing it in unexpected ways, amplifying gravitational waves. When gravitational waves enter the void area, you will encounter a strange physical environment dominated by dark energy. Dark energy doesn't just push space away. It also interacts with gravitational waves, may amplify certain frequencies. At the same time, other frequencies are suppressed. This amplification effect means emptiness may be the natural universe. Gravitational wave telescope. Automatic enhancement comes from the farthest reach. Signal from the oldest source. The wooden constellation is hollow, with its extreme dimensions and near total emptiness. Possible. It is the most powerful natural gravitational wave in the universe. One of the amplifiers. Recent measurements has been vaguely captured. Gravitational wave signals coming from the cavity area. Its intensity far exceeds the level predicted according to the source. If this finding is confirmed, that means the void is not a passive channel. Instead, it is actively dealing with gravitational waves. Through mechanisms that we do not yet understand, filter and amplify it. The impact is shocking. If the hollow can really manipulate gravitational waves, they may still be like cosmic lenses. Focus on these waves. Put it from a specific direction, or the signals of a specific period are concentrated. This will allow us to achieve unprecedented precision. Peek into the farthest corners of the universe and the earliest epochs. We may even detect it. The first generation of stars formed the first black holes. Even in the first moment of the birth of the universe, the quantum process that occurs, the gravitational wave signal emitted. But hollow enhanced gravitational wave astronomy, it also opens up a disturbing possibility. If the cavity can amplify the gravitational wave, they may also be passing through some cosmic scale. The process actively generates gravitational waves. So, in the depths of the super-empty, seemingly empty, what exactly happened? It can actually generate detectable gravitational wave signals, penetrate deep into the hollow of the woody constellation. The conventional laws of physics began to crumble. As the density of matter falls below the critical threshold, areas where dark energy is completely dominant, the way the space itself behaves, it is challenging our most fundamental understanding of reality. Einstein's general theory of relativity predictions. In very low-density environments, the curvature of spacetime should be close to zero. That is, a flat space that stretches infinitely in all directions. But the actual measurement of superhollows, it reveals a completely different phenomenon. The direction of spacetime bending. It is actually a bend caused by matter and energy. Quite the opposite. This negative curvature, it suggests the existence of some kind of gravitational repulsion effect. A strange substance with negative mass and negative energy. Negative mass is physics, one of the most taboo concepts. It will fall upwards instead of down. Will stay away from ordinary substances. Accelerated movement. It also violates the law of conservation of energy in amazing ways. The vast majority of physicists believe negative mass cannot exist. It only belongs to the category of science fiction. However, the gravitational effect observed in the cavity region, it gives a lot of negative mass, evenly distributed in these seemingly empty areas. Highly anastomatic. Computer simulation display. Even if only a small amount of negative mass is present in the cavity, it also explains why they are inflating so quickly, why resist galaxy formation, and why it has become more and more empty over time. Negative mass will actively push away ordinary matter, and as the cavity expands, its repulsive effect will continue to increase. But negative mass brings a paradox. If it really exists in the void, it should pass through its neighboring galaxies, and the gravitational effect of galaxy clusters was detected. The boundary between the void and the cosmic mesh structure. It should be revealed. Clear traces of the substance being repelled by the negative mass concentration zone. However, these boundaries are unusually stable. The galaxy maintains its normal orbit. There is no sign of negative mass interaction. This has prompted scientists to propose even more bizarre conjectures. The cavity may not really contain negative mass, but through quantum mechanical processes on a cosmic scale, negative mass effects are simulated. Quantum field theory points out, vacuum is not really empty. Instead, it is filled with imaginary particles that are constantly being generated and annihilated. Yes, under normal conditions, these quantum fluctuations have zero static effects. But in areas where dark energy dominates the rapidly expanding space, the quantum vacuum can become asymmetrical. If the space expands at speed, exceeds the speed of annihilation of virtual particles, it may be on the cosmic time scale and the hollow scale, leaving a net excess of negative energy particles. This effect accumulates enough to produce observables. Gravitational repulsion. This quantum negative energy can explain the expansion of the void. There is no need to introduce it. It should have been by other means, detected exotic substances. But quantum explanations lead to even more bizarre prophecies. If the whole is generating negative energy through a quantum process, they should trigger other singular effects as well. For example, the destruction of energy conservation generated by spontaneous particles, even through quantum tunneling, connect with parallel universes. The latest theoretical research suggests areas with extremely strong vacuum energy like supercavities. It may create a condition, a barrier between our universe and other possible universes, gets thin enough, sufficient to allow the exchange of information. If true, that means emptiness is not just an empty area inside our universe. Moreover, leads to a real world that is very different from other physical laws. Potential gateway 2. But the vacuum effect of the subvacuum is probed in the cavity. Measurement accuracy that is close to the physical limit is required. This will put our technology and theory into understanding, push to the absolute boundary. We are in these cosmic laboratories of forbidden physics. Something found. Maybe it will change completely our definition of reality itself. Some kind of mechanism is systematic. Extract matter from the largest void in the universe. And the process is accelerating. The past 30 years, comparative measurement of cavity properties revealed a disturbing trend. The most open area. It is moving at a rate that far exceeds all theoretical predictions. It became more and more empty. Not only are substances unable to aggregate in these areas, instead, it is actively withdrawn and transported elsewhere. Since the beginning of detailed observations, the Pythagorean cavity has lost about 15% of its remaining material, gas equivalent to billions of times the mass of the sun. Dust and dark matter disappeared from an already almost vacuum zone. Where did these substances go? Tracking study form. The material that was taken away was not randomly dispersed. Instead, along a specific path, flows to the densest regions of the cosmic web, those galaxy clusters and superclusters. And there's already extremely negative material. These forms one